Okay, so now we're going to teach Sage the Gram-Schmidt algorithm. To use Gram-Schmidt, we need a couple of things. We need an inner product, and we need a norm. An inner product takes in two inputs and returns a number. For the inner product in this video, I'm going to use the L2 inner product on the interval from 0 to 2. Everything in the post-class 15 is about the interval from -1 to 1, so you'll have to adjust some stuff when you do this. But I want to return the integral of f times g across the interval that I'm considering. I also need to define a norm. What is the norm of a function? It's simply the square root of the inner product of f with itself. Okay, let's see if that worked. Let's give ourselves a couple of functions. Okay, so yeah, it seems like at least we're getting answers. Presumably we could compute those answers by hand and we would get the same result. Okay, now let's do Gram-Schmidt. What does Gram-Schmidt do? Well, Gram-Schmidt starts with a basis. I'll call that basis B. And the first element of the Gram-Schmidt basis is you take whoever the first element of B is, and you divide that by its norm. So at this stage, you've only defined E1, so the basis so far is a list of length 1. Now, to get E2, you have to look at E1. To get E3, you have to look at E1 and E2. So at each stage, when you're building up the Gram-Schmidt basis, you're looking back at how far you've come so far. Here's how we're going to implement that. So we're going to go through B and do the following. First, we pick out the kth element of B. Notice that in Sage, indexing starts at 0, so the first element of B is B0, the second element is B1, the third element is B2, etc. That's why this index k here I have starting at 1. Okay, so what do I do to that kth element? I project it onto the span of the basis so far. So what does that projection look like? Well, a projection, it's a sum of terms, each of which looks like you take the inner product of the thing you're projecting with the basis element you're projecting onto, and then multiply that by the basis element you're projecting onto. And a nice little quick Python code for doing this is basically just to write down exactly what you want to happen. Then you're going to get a list, you sum that list, and that's the projection. And then you should get B minus the projection is what we called V in our description of this algorithm, and then the new element of the Gram-Schmidt basis is simply V over the length of V. So we compute that, and then we are going to add it to the basis so far. Once we're done with all of that, we're going to return so far. All right, so now we're working with this inner product, so let's say we work with P4. Then we need a basis for P4. So let's start with the standard basis, and B will just be these guys thrown into a list. Now let's compute the Gram-Schmidt on B. Thanks for a while. And let's see what kind of a thing we had. It's a little bit hard to read, so why don't we ask it the Gram-Schmidt basis of B, and we'll just pull out, say, the third entry of that list. Notice this is going to be a polynomial of degree 3. You should satisfy yourself that's the right answer. So let's go ahead and see what this guy looks like if we plot it. So we use the plot command, and there we go. You can see we have a nice picture of this function of degree 3. And this picture kind of indicates some interesting phenomena happening here. Should raise some questions for you.